Hi, I'd like to welcome everyone to our GDC session. This one's entitled Building Beautiful Worlds with Gaia ML and the OpenVINO Toolkit. We'll give you a preview of our new Intel Game Dev AI Toolkit and some of the powerful features that are enabled through that. Some quick legal disclaimers for you folks, and then we'll get right into it. My name is Peter Cross. I've been at Intel more than 20 years, involved with a lot of software development and architecting for our semiconductor factories. Recently, in the last couple of years, I moved over into our game developer enablement programs, and I'm supporting graphics and game dev community engagement within that scope. So Adam Goodrich, who was one of the folks I met through this program, I'd like to introduce you to him right now. Adam?
Hi, my name is Adam Goodrich, and I'm the founder of Procedural Worlds. My background is 30 years of tech in the enterprise space mostly, and then the last 10 years on Procedural Worlds, and we create tools which help people to create worlds for games.
Excellent. So I'd also like to acknowledge one of the big contributors to this project, Christian Mills, who was one of the pioneers for this Game Dev AI Toolkit. He developed several IDZ tutorials for us last year, and we are very thankful for the contributions he made to this toolkit. And he has a passion for Unity and Unreal and enabling AI and ML in those spaces. Thanks, Christian. So if you recall our GDC presentations from last year, we teased a little bit about what we were going to come out with this toolkit. We talked about some of the use cases for AI and machine learning within the game ecosystem. Things like partitioning game workloads across different pieces of silicon, the CPU, GPU, VPU. Also, its usage in creation of realistic in-game NPCs, things like high-performance speech recognition, as well as creating massively open worlds, and also assistance for hearing and visually impaired gamers. We introduced you in that session last year to our OpenVINO toolkit, which provides an end-to-end solution for deep learning. Build your models, deploy them, write once, deploy everywhere. So this slide shows an end-to-end workflow of inference optimization with the OpenVINO toolkit. Users can build their trained models, for instance, object detection and style transfer, which you'll get a taste of in Adam's demonstration later. Also, there's the Open Model Zoo, where there's hundreds of pre-trained models that users can pick and choose from and add to their game experiences. So the next step is optimizing with the model optimizer in OpenVINO, where the IR representations are converted into the inference engine models. And then lastly, deployment. As you see here, it's easily deployed to a number of Intel silicon platforms ranging from CPU, GPU, VPU, and everything in between. So it's a perfect solution for end-to-end workflow for deep learning. Now, getting into our Game Dev AI Toolkit, what is it exactly? So we view it as an opportunity to bring game developers brand new tools that accelerate their game development, that also provides new AI-driven capabilities that were previously unavailable, only to the AAA studios in many cases. It runs on a wide range of hardware, not just Intel hardware, but all the platforms that Unity supports. And that first version is targeted for Unity developers, although we're looking at adding UE5 support later in the year. Now, the Intel Game Dev AI Toolkit differs from a lot of our offerings in the game developer space. It's not focused on improving graphics quality for games, for instance, like our denoiser and XeSS products, which we'll be talking about in other sessions. And it's not focused on performance tuning aspects like Intel GPA, which also has another session here at GDC. And it's sourced from our external graphics innovator community. So I mentioned Christian Mills' work earlier last year. Much of the toolkit is based on his tutorials that he created for our Intel Developer Zone. Also, it integrates with third-party assets like Procedural Worlds' popular Gaia tools. Now, this slide shows a lot of the different use cases for AI in gaming. As I mentioned, Intel is mostly focused on that lower left quadrant until now with our XeSS denoiser products. But, we'd like to expand that footprint into touching into a number of other areas that AI applies to. Things like style transfer, 3D object reconstruction, facial animations, game physics, reinforcement learning concepts like smarter NPCs, game assistance, anti-toxicity things. So with this first release of the Game Dev AI Toolkit, we're targeting 3 different areas of capabilities. One is style transfer, real-time style transfer, that is, and the other is object detection, in-game object detection. World creation is part of the integration with Gaia ML, which Adam will speak to more in a few minutes. But things like style transfer, being able to apply different styles, turn your game into a Minecraft style game instantly, or be able to augment certain parts of the screen at different times. We believe it's a powerful feature that game developers will use. Object detection is also an amazing feature. It can be used to help visual or hearing impaired gamers, and can be combined with other components like that style transfer to provide augmenting for holiday stylizations or in-game buildings, things like that. Now here's a high-level view of the architecture for the Game Dev Toolkit. You'll see that it integrates with Unity through the inferencing layers, OpenVINO in this case, but it's also enabled for Unity's own inference engine, Barracuda, as well as we're looking at adding DirectML at some point. So it uses the Unity scriptable object system for easily adding new ML configurations. Very modular architecture that we hope game developers will find very useful. And with that, I'll turn it over to Adam to talk about their work with the AI Game Dev Toolkit.
Thanks, Peter. Before I jump into the demonstration of the cool new technology we've been working on, I'll just give you a brief introduction to Procedural Worlds. We've been around since about 2012. We launched our first product in 2015, which is Gaia. We're a Unity service delivery partner, we're an Intel partner, and where we specialize is in procedural generation tools. We work across a broad range of industry, studios, and indies, and we've worked with some really, really interesting projects over the years, world creation from mapping sources and so on. Typically, people use our tools to generate environments for games and simulations, and increasingly we're doing more work with real-world environments, the Internet of Things, and mapping. Let's talk a little bit about Gaia. Gaia is a world creation system. It allows you to create worlds in hours and minutes instead of days and months. We have a typical process whereby we use a stamp to shape the world, and then we use a biome to apply assets into the world so that we get beautiful texturing, trees, plants, buildings, and so on. And the biomes that we apply to those environments can either be with our assets or yours, so you can make them anything you want. Gaia is the best-selling terrain tool ever since it launched in the Asset Store. It basically has been in the top 10 assets, best-selling assets, pretty much since it launched. It was awarded Best Artistic Tool in Unity Awards 2020, and we have over 1,000 reviews. So Gaia ML is a version of Gaia. It's the same basic core. And what we've done is we've integrated the Intel AI Game Dev Toolkit directly into Gaia. And we've wizard-enabled all of this, so it's really, really easy to apply this into your scene. It's free, and it's supported by us. And it's whether you're using Gaia ML or one of its bigger brother products like Gaia Pro, it will work equally as well. So we've built an integration layer which makes it easy to plug into any system and any tool. So Gaia ML, its bigger brother, has a bunch more tools, a bunch more assets. It's capable of doing large worlds and streaming. With that, let's jump into it. To start our demonstration, let's create a world with Gaia ML. We'll add some custom terrain features, some roads and rivers, and then we'll press play. Here is an empty Unity scene. We'll go to Window, Procedural Worlds, Gaia, show Gaia Manager. The Gaia Manager is a wizard-driven system that handles the heavy lifting of setting up your project, creating your world, creating your runtime, adding inference, and then building and deploying your project. Let's go to Create World. Inside of this wizard here, we can choose the size of our world, or if we want to, with each of these settings, we can go in and manually customize them, so we can make multi-tile terrains and so on. We'll choose the target platform, the target biome. Now, a biome is a collection of assets and the rules that we need to apply those assets to the terrain you create. So these assets typically will consist of terrain textures, grasses, trees, rocks, buildings, or whatever you want. Gaia ML comes with some sample biomes, and Gaia ML's bigger brother, Gaia Pro, has a whole bunch more biomes. And if you want, you can create your own biomes to use your own assets. Then we'll choose our workflow. We could either have the world designer do all the work for us, or we could do it manually with the stamper to create exactly the world that we want. So let's create our world designer with these settings. What's happening now is Gaia is generating a start terrain and has generated a low fidelity mesh so we can visualize what our environment would look like. So let's zoom in and see what it's done. This is a pretty cool starting point, but I'll talk a little bit about the settings here. So you can choose your world size and biome. You can choose the shape of the world, which is the default shape. Think of it as the base of the continent, for example. And then you can choose the details that Gaia will fill in on your world. And these details are this feature versus that feature. So it's like it guides the way in which the world is created for you. In this case, we'll just keep the defaults and I'll hit randomize stamps to create another world. That looks like a good starting point. Let's generate that world. Now what Gaia is doing is it's doing all the heavy lifting. It's creating a Unity terrain, it's applying assets to it, and it's just textured the terrain for us. We also have a blue plane that is the simulated water level. So let's go in and have a look. Pretty nice little environment, bit of lowland area here. Let's actually go and customize this and make it a little bit more, give us a little bit more land to work with. I'm going to go to my manager, advanced tools, and we're going to add the Gaia stamper. Now the way Gaia works is that it treats the underlying terrain like cookie dough. And then what we do is we stamp different shapes into that terrain. In this case, we've got a set of hills which don't really match the environment, and we can flip through the different types of environment, different types of landscape that we'd like to put in there. I want a fairly flat area, so I'm going to maybe grab some plains and we'll flip through some of these. That one looks okay, and we'll choose this one. Now what I'm going to do is make that smaller, move it over here, and you can see we've got this interesting little bit of terrain here which we're going to expand our area with. And what I need to do is blend that terrain into our overall environment. So I'm going to add a mask. I'm going to choose a distance mask, and then I'm going to make it circular. Boom. So we just got a little area of influence here. We'll make that global so you can see how it's affecting with the terrain around it. So now we're going to lift up this area and create a bit of a wider area in our environment. And this is one of the lovely things about Gaia. It makes it really easy for you to customize your environment. There are many, many more things you can do here. I might just flatten this down a bit and maybe lift it up a little bit. So we've got a nice flat area on which to build some cool things in our map. So let's go stamp. And there we have it. We have some nice extra area. Okay, so let's now add some buildings and some roads. So this next thing I'm going to do is let's grab a small town, actually maybe a villa, into our environment. And we've got a visualizer here. Now this is being done with another tool of ours. It's called Gina Pro. And our villa, our environment here is not very large. So I'm going to cut this villa into the sides of the hill. I'm going to point it in this direction. And I'm going to do that. So what's actually happened here is we've flattened the terrain around there. And we place this structure made out of lots and lots of bits onto that area in the terrain. Now, because this is so small, we might just put something else here. Maybe a church, and point it back that way. And again, spawn that in. So we've created our world. We've added some structures. We've added a bit of extra land. And now I'm going to add some roads. And click here, Gina, add road spline. And I'm just going to click where I want that road to go. I'm going to maybe extend it around our island a little bit. And maybe bring that back in here and over to here. So these roads, these are all procedurally generated. And this comes out of work we've done using mapping. And we can actually go in and modify that road. And you'll notice that the road cuts into the terrain and it doesn't actually fit perfectly within the environment. So the next thing we're going to do to our road is we're going to carve it into the terrain. So let's do that. I'm just going to go carve, boom. And now our road is nicely integrated into the terrain. Let's see if we can fix this a little bit up here. Sometimes it's not a perfect match and you have to do a little bit of extra work to make it work nicely. There we go, conform to ground, and then we're pretty good. All right, so let's add some street lamps to our road. So I'm going to click on our road spline here, and we're going to drop our street light onto it. And what we've got here is a visualization of where that would actually be added into the terrain. We're going to change our flow rate and extend the distance between these things. And then we'll also get it to check for intersections, so it won't draw in the middle of an intersection. We'll offset it by 4 meters, so it's off the edge. And let's spawn those street lights. So we've now added some street lights, but you notice they're all pointing in the wrong direction. So let's fix that as well. We're going to go to Align to Spline, Align Children, and then we'll offset our rotation. So they're all now nicely aligned. And we can do a lot more with this, but that's just a quick example of the power of some of these tools. To finish this off, I'll just press spawn in our biome and we'll see what Gaia does for us. Clicking here and hit spawn. What's actually happening now is running all of these different spawn sets and these spawn rules against our environment, and we've populated it with some trees and some grasses and so on. I'll go back to my manager, and the last thing I'll do is I'll create my runtime. Now this is adding in things like your player controller, your time of day and your skies, the type of water and so on. Again, this is a convenience thing and makes it nice and easy to use. Boom, and let's press play. And here we have, in a matter of minutes, an entire world all nicely filled in with content and a perfect starting point for your machine learning projects. For the next part of our demonstration, we'll add style transfer to the environment we just created. To add style transfer to our scene, we'll go back to our manager, and then we'll select our Inference tab, and then we'll select the style transfer model. In this case, we'll use OpenVino, but we could also use Barracuda if we wanted to. And the options for this style transfer are in here. I'll just take the defaults and I'll go apply. Pop this out the road. Let's have a look at our Inference Manager. These are the settings for this. And let's just press play and see what we managed to do. And here we have it, style transfer, all running nicely on my GPU. There's our building from before. Rather cool. We can do things like we can switch it from CPU to GPU, and there are a bunch of other settings here, and a little bit later in our presentation I'll take you through how you can create these yourself. For the next part of our demonstration, let's add object detection to our scene. To add object detection to our scene, the first thing we need to do is go to our manager, go to our inference, and select our object detection, our Coco Yolox model. It's using the Yolox large model and it's running on the GPU. So let's click add or apply now. Boom, it's added to our scene. Now let's give the model something to work with. I'm going to go over here and grab some of the props from a free asset pack called the Flooded Grounds. Let's see what we've got here. Pop a boat in and quickly rotate this guy. Drop it down a bit, because you never know when you might find a boat in the middle of the road. And let's add a car. And a chair. What else have we got here? Add a table. All right, that'll be enough to show the concept. Let's see how the system handles this. Cool. And what you can see now is Yolox giving us a percentage of confidence in the fact that it's detected the different objects within our scene. It's working pretty nice. There's our truck. Here's our boat. Here's our chair. And here is our bench, or a bit of table. Maybe not. Let's call it a dining table. There we go, almost got it. For this next part of the demonstration, we're going to create a rail shooter from scratch. We'll add in a loyal wingman, and then we'll bring that wingman to life with machine learning. For this next demo, I've gone to a new project where we've installed our rail shooter game template. I've created a new scene, and now we're going to create a low poly or a simulated low poly environment with our world designer. So let's just quickly do this. Create our preview. And then let's generate our world. Now this time the biome and the assets we're using are more of a simulation of low poly, so you've got a different sort of look from the environment, and that demonstrates very quickly the power of the biome system. Let's just spawn our biome and then look at what we've done. That'll do for a starting point. Then the next thing we want to do is add in our rail shooter game template. Boom. Then we want to go to our manager, and we're going to set up a custom camera. I'm going to drop in our controller and our camera. So I'll drop in our controller, and we'll drop in our camera, and then We've got our low poly environment set up here. Looks good to me. Let's just create our runtime. Yep. And now we've got a nice environment set up here. Let's press play and see what we came up with. And here we have our cool little fighter flying through our scene here, zooming out, a couple of shots. Then let's add in some enemies. To do that, I'll just use Gina to spawn them in. And we'll put some enemies here. So you see it's spawning in some ships, and then some enemies there, and some enemies there, and here, and here. All right, now let's see how the game goes with our enemies. Okay, so there we have a simple game. The next thing we'll do is we'll go and add our ally controller into the scene. And let's press play again. Okay, as we start now, we just wait for our little loyal ally to sync up to us. And then I'm just going to zoom out a bit. You can see the enemies firing at me. And here comes our ally, and it's now shooting at the enemies. You notice the red box around the enemy ship. That is the current target of our ally. So let's wander over here. You can see some more enemies, and there's my ally down to my right. He's chosen a target, he or she, and is now shooting the target. As it finishes one, it then comes on to the next. And I might just mute the audio because you don't need to hear that. And now what we're going to do is add machine learning to this. And again, it's quite easy to do. We'll go to our Inference tab here. So expand this out a bit. And we're going to use the Cocoa YOLOX. In this case, we're using the nano model. So let's add that to our scene. Apply. And this time what's going to happen is instead of my wingman choosing the nearest enemy by itself, we're actually going to use machine learning and object detection to control what it shoots at. So let's see it. So here I am, and there's my wingman. I'm just going to zoom out a bit so we can get a good view. And I'll just actually head out to sea a bit. As soon as I get far enough out, our little wingman will come and join us. All right. Now this wingman, it's actually it's generally, it will follow me, but as soon as it finds something, you notice there's some blue boxes and some red boxes. So what's actually happening is we're using object detection to work out what an enemy is, and it's just spotted another one off over there. And it's gone out to fight it. And then when you see the blue boxes after it's killed that enemy, those are the other objects, and it will basically wait and then select one, and then away it goes. So it's actually quite effective, really. Let's go and try and zoom out even a bit more to give you a last look at that. So here we go. You can see the AI has detected that these are all enemies, and it's chosen one over there. We'll go over there with it. Try and avoid these other fighters ourselves. It's choosing more objects, and there we go. That's what it's aiming for right now. So that's a very, very powerful, and it's a simple but powerful example of the use of object detection to actually influence your gameplay. The next thing we'll talk about is how is it happening. So let's go and have a look at how that's actually happening. So if I look at my ally controller, I've got all my settings here. But right down the bottom, we've got an ally bounding box script. And this is the way in which this is the script that's doing the interface between the object detection and the game mechanics. So let's have a quick look at this. Now a lot of this is just set up. Let's look at the interesting part of this. So I'll just go to our update function here. So we clear out the blue boxes, just tidies things up. And then we're saying that if we if the object detection is not in the scene, then drop out. And then what we're doing is we're only evaluating objects if we don't already have a target. So if we don't have a target or our target is dead, then let's activate our object detection. Let's get all of the objects. And then if they have a bounding box and they're active, we're going to create a new list of enemies. And then for each object that's been detected by the OpenVINO inferencing engine, then we'll actually grab the bounding box of that object. We'll do a raycast to it, because what the object detection is giving us is just the area on screen where it's detected that object. So what we're doing is we're basically seeing what the object is at that location, and then we're checking what the object detection thinks it is. We're checking whether or not the confidence for that object is high enough, and then we start processing it as if it's an enemy. So the interface is actually quite simple, but it's profound what it's doing, because essentially it's searching through the scene, recognizing an enemy, and then attacking that enemy. So now let's talk about how do we create our own AI ML extensions. So to find out how we do this, we need to look in the AI Game Dev Toolkit. We've got our inference engines there, our scriptable objects here, and our scripts here. So in order for Gaia to show something in our inference interface, it needs to find it in your scene or in your project first. So essentially what we're looking for is a scriptable object that's derived from a particular base class, and then if we find that in your project, we'll call the display and the display interface methods in here, and then you can go in and edit your settings. So let's have a look at what's going on. If we go to our inference feature, this is our base class that we are deriving from. We've got our features, we have various methods which you can override, initialize your drop downs, your inference, your cleanup, applying it to the scene. So depending on how you've set up your machine learning, it might need to be set up in different ways, and that's fine. As long as you are implementing these virtual methods, then this thing will just run within the Gaia base interface. So we have various versions of this, each of which add more and more information. And essentially you need to create specific classes which are derived from these, then create instances of your scriptable objects which are derived from those. And inside of your class, this is where you're going to set up all your settings. So the beauty of this approach is, as long as you derive from that base class and implement your own data and your own UX, then it will be displayed inside of the Gaia Inference tab, and then that allows it, that makes it really easy for you to then share your configurations with other people. All right, so to finish up, what we've done is we've shown how you can use Gaia ML to create scenes. Then we've added style transfer to those scenes. We've added object detection. Then we've created a game using one of our game templates, and then we've modified that game so it's using the object detection to influence what is being attacked by our little wing commander. So to get access to Gaia ML, you can go to Canopy, which is canopy.procedural-worlds.com, and you can download the AI Game Dev Toolkit for free with Gaia ML. Now we have embedded the AI Game Dev Toolkit inside of Gaia ML to make it all easy. All you have to do is install your package and away you go. We've got access to forums where you can ask questions. We've got tutorials, and essentially we will support you if you're using Gaia ML with the AI Game Dev Toolkit. And thank you very much for listening.